All right, thanks everyone for joining us today. Real quick, is there anyone that is joining us for the first time today and would like to say hi?
Hello, I'm here for the first time. My name is Bas van Beek and I work with Emmanuel on Open Census.
Oh, nice. Welcome.
Thank you.
Hi, this is Pau. Also, it's my first time. So, hi, everyone.
Hi, welcome. Thanks for joining us. All right. Well, yeah, Emmanuel has a lot of interesting stuff he's going to share with us today. We're very excited about. We also had a couple of announcements here that we wanted to, or I guess maybe just one announcement here we wanted to share first.
So hi everyone. We're gonna publish nightly builds of gRPC packages to help people who have continuous integration infrastructure and they use gRPC to be able to test their system with the latest daily gRPC build, so that we can catch errors early, and they can also see if their system has a bug or is relying on unsupported gRPC behavior of the previous version and therefore might break due to the next release, to understand the situation early on. So we actually sent out a form to grpc.io, and I think we're going to have it in the doc, the link to the form, for people who are interested to sign up for package builds of gRPC core. This applies basically to C#, Python, Ruby, PHP, Node too. And we're going to have that soon. So this is a form for people who are interested in having early access to that repo. Of course, this is in addition to our release candidate process, which we already have and have had for a while. So that is my announcement today.
Awesome. Anybody else have anything we want to share from the team here?
So I might have a small thing. So
you should say hi, because like no one's ever seen you before.
Okay, so people have seen me before. So hi, I'm Jan. We've been working on improving the test infrastructure for gRPC, over the last few quarters. And then one thing that you might have realized, but you also might not, is that the way the test results are presented on the pull request. Like all the test results are not public, and you have access to like the structured test results, which we hope is going to improve like the experience for the contributors, because before it wasn't easy to access those test results and like understand what they mean. So right now, when you create a pull request against our repo, like you're going to see all the test results publicly, and yeah, as I said, there's like they're presented in a way that's hopefully much more understandable than it used to be in the past.
Anybody have any questions or? All right, then I think we can turn it over to Emmanuel.
All right. Oh, hello, everyone. Good morning, good afternoon, good evening. My name is Emmanuel Odeke. I work in Open Census. I also work in the Go programming language at Ridge Tech Inc. And today I'd like to talk about integrating Open Census into gRPC programs and any kind of program. Let me create this quick presentation. Give me a sec. I need to share my screen. All right, can everyone see this? Yeah.
Yeah.
No, thanks. So anyways, planet scale observability with Open Census for gRPC in Go, Java, and Python. Who am I? I'll just introduce myself. Emmanuel Odeke. I'm an avid open source consumer and producer. I work in the Go programming language as well as Open Census and distributed systems at Ridge Tech Inc. I really enjoy using gRPC. Why open census? Low latency overhead, provides you modern instrumentation. It's microservices friendly. We have a mechanism called context propagation, which I'm sure many of you are aware of, that allows you to propagate information across RPC boundaries. Okay, open census is vendor agnostic, cloud agnostic. That means you could run it on your computer, AWS, DigitalOcean, Google Cloud, Azure, and from that you could export and export traces and metrics, send them to Prometheus, X-Ray, Stackdriver, SignalFX, Instana, Zipkin, Jaeger, you name it. We have a really simple API, and in order to export, in order to export to a backend, all you need to do is you implement an exporter interface, register it in your main program, and that's it. The rest is handled for you. These are validated ideas that come from running at scale at Google for the past 10 years. Internally, they have a system called Census, and Open Census is the open source rewrite, right? All the work is done entirely in the open. And we do that at github.com/census instrumentation. Open Census is implemented in Go, C++, Java, Python, Ruby, PHP, Erlang, C#. Other language implementations will be coming soon. You don't need distributed systems expertise. So I've gone through this at startups where you need to roll a product out, but as you keep building products that run at scale, you encounter all sorts of crazy problems. So with Open Census, you don't have to be a distributed systems expert. All you need to do is just import Open Census in the language that you're using, and that's it. And in fact, you could have polyglot microservices, and if each one of them wants to use Open Census exporters, if you have in Java, Node.js, Ruby, C++, Python, you name those, you'll still be able to use Open Census. Quick primer, tracing. Tracing is a mechanism by which you track the progress and behavior of a remote procedure call, or it doesn't even, it could be even a function call. Basically, track any behavior through a system. Monitoring, that's the mechanism by which you collect quantifiable metrics of your system. For example, server latency, client latency, number of file descriptors open, context propagation, which I introduced previously. That's a mechanism by which you send distinguishable information about a request across RPC boundaries. Tags, then the next concept is tags, key value pairs attached to metrics to help you uniquely identify whatever you're measuring. It could be host is equal to some IP, user agent, coming from a programming language. But tags are used for metrics. So that's an important thing to note. And then for traces, we have annotations. So annotations help you describe the state of a trace and the status quo of your system at the time that you made that annotation. And I made a bunch of promises. It's time to walk that talk. Okay. So right here, I have this website. So, we've launched a new app. We've launched a new app that allows you to search YouTube, that allows you to search for videos on YouTube, right? And after we've launched it, it's running at scale. We need to figure out what exactly is going on. Without a way to clearly track metrics and also figure out how traces propagate, most of the times you're flying blindly. And even worse is the fact that any interaction between microservices becomes really complex to reason about. In that, if you have, say, for example, 4 microservices talking to each other, when one makes a request to another and it propagates to the next, throughout all those 4, the call graph becomes complex because, there are more than at least 8 routes that you could take within that call graph. So Open Census helps you that. anyways, here is a backend that I have instrumented with OpenSensus, this YouTube search app. And once we, once we hit search, it searches for Fugazi. In here, its backend uses Stack Driver, and I'll also open up X-Ray. Oh Lord, give me a sec. The demo gods aren't working well for me. All of a sudden, my screen, my keyboard won't pop up. Let me turn it off and back on. Sorry. There we go. Okay, so I'll open up X-Ray AWS, and that's another backend to which we'll be exporting our traces. Okay, we'll open up AWS X-Ray, and the other one that we'll open up is monitoring, Stack Driver monitoring. Okay. So in here, I'll type, say, for example, gRPC, do that search. It takes a bit of time. So the first call wasn't cached, subsequently cached it. And when we go in here and search, let's visit that. In here, it shows a trace of what exactly happened. So to give a bit of background, this is an app that I instrumented with. This is an app that I instrumented with OpenSensus. I instrumented also its front-end server, and its front-end server uses Caddy. Caddy is a modern HTTP2 server. It's also written in Go, but yeah. Yeah, so I instrumented Caddy as well, and here is a code for it. It sends, it also uses Prometheus to collect, it exports metrics to Prometheus as well. But anyways, here is what a request that was cached looks like when we view it on Stack Driver tracing. So we could see, we received a request here. It went through Caddy the HTTP server, and then in here, this is actually where we started processing the request. So here we have an annotation that we made. We say check cache if query is present, right? And we noted that this is a driver that we'll be using. It's Mongo. We're using MongoDB in Go, and we noted that we had a cache hit here at the very end. But this is how it propagated. We extracted a query, parsed it. After that, we searched our MongoDB cache to find out has this query been seen before? If it was, sure, let's well and good, let's cache it. And here we have, let's see, we have a bit of an outlier here. And this is typically what happens when, this is a normal request, and it shows the reason why we're even using caching. This normal request takes about 293 milliseconds. And when taking a look at this request, we note that we searched Mongo, we did a find one here. When searched through Mongo, we didn't find anything. And then we made an RPC, we made a gRPC call to this backend that performs search. And in here, you could see in search it processed a trace. Let me show the code for this. Okay. Yeah. So this is a /search. Never mind. I'll get back to it. Let me progress through the demo. So, anyways, at the very end here. I'm just trying to find the exact code. It would be an RPC, sorry. Okay. So this is a gRPC backend, the one that performs the actual search. And in here, you'll see we started a trace. We say trace the start span, and while exiting this function, we did a defer span at end. And we can get the full story of it, of how everything happened. So search it. We know that search it, okay. In here we had a cache miss, so we had to actually search the YouTube API. We made a we made an HTTP call to YouTube's API to search for that query and in search for that video. And in here you'll notice our user agent was the Go API client, and our agent here was OpenCensus Go. Our trace has it has this distinguishable information, status code 0, 200, and it also shows a path. Now, so anyways, this is basically all that we had to add in order to get a bit of to get observability. Let's look at let's look at the metrics. Oops. Metrics overview. Global. So remember I mentioned Caddy was instrumented with OpenCensus. Let's look up latency. What are we having for server latency? In that stacked area, you can see that P99 P99 latency of our system currently to about 300 milliseconds. And anyways, now let's simulate a bit of load. So to simulate load, we have this simple Python client. It's going to make a query to. It's going to make very many queries to this service. And what it does is it opens up a text file, Gulliver's Travels, which is it's half a megabyte. It has half a megabyte, and it will pull out line. It will go line by line, extracting out lines in order to make queries to that backend. So let's do client.py. Let's simulate a bit of load. This is what happens when, this would be pretty much what would happen when your service gets really popular. Just make a whole bunch of them. All right. And I haven't shown you what it looks like on AWS. So this is a cache hit. This is what it looks like. This is the exact same data that we saw in Stackdriver, but exported to AWS X-Ray, right? And this is what I was telling you about. It gives a nice view. We made a search, went through Caddy, went down to the actual backend, right? We had a front-end server, good proxy to the backend. And then, we extracted the query. We extracted the query, searched MongoDB, didn't find anything. Then we invoked the actual search API. Right? And it shows shows the full request. And then a nice thing with distributed tracing is all of a sudden you get a map of how services are propagating, of how requests are propagating. and how your services interact. So this is a really simple. It's a really simple back end. It just has a front end and one back end, which is the main app, and then on a gRPC based back end for actually doing the search. So this is what it looks like. If we go back to our traces, let's see. Let's sort them by response time. Okay. So these are sample requests. Let's also look at our metrics. Yeah, this is what it looks like. And then, anyways, that's so far the demo. I wrote in the docs. I created an introduction, which it's a primer to using gRPC. Sorry, Open Census with gRPC. I made for Python developers, for Java developers, and for Go developers. And if we click in here, it's just basically going through a bunch of the steps that I provided. There's a quick introduction here. And this actually, let me quickly go through this. So this is an RPC definition for a service that capitalizes content. You send in content, capitalizes it, and sends it back out capitalized. Shows you how to generate. This is using Go. And here we make our plain server, which would be the normal case before you've learned about Open Census. This is typically what your server will look like. 38 lines. And then, we have a Go client as well, equally as large. And this is, these are the interactions of what it would look like. So you send in foo, it echoes back, foo capitalized. Say what, that's a drill. We're open for business. So anyways, the problem that I mentioned, you just launched a new service. You launch a new service and all of a sudden it gets really popular. You don't know what's breaking. Things are taking very long. So, for example, say your latencies start to hit close to 1 second. Yet in testing, you saw that a search took usually 1 millisecond. So Open Census will help you with the sample traces that you get. It helps give you tell you a bit of what's going on with your system. So, the sample traces that get exported to your backends could be viewed here. Stack driver tracing. So you'll have something that's like a 248. That's a normal case. Occasionally, you'll have something that's really an outlier. So if you clicked in that, it would show you what's going on exactly. And I believe Stackdriver will be rolling out with a feature where you could link a trace to a metric to a trace. So you do a reverse search. So in here, you plausibly could click on that point, ask, hey, by the way, could I find traces related to this? Because in Go, we associate tracing and metrics using the same context. So that's a feature that plausibly will be coming up. So anyways, back to that tutorial. This is the diff on how to add Open Census instrumentation to your Go app. Here we have an exporter for AWS X-Ray. We also have one for Prometheus and Stackdriver. In there, remember I mentioned this is how you start a trace. This is how you start a trace. This is how you end it. This is how you add those annotations that we saw. And in here, here is where we define the different exporters. So we could define what our service will be called, etc. And at the very end, after we're exporting to Prometheus, we'll get a view like this. Right? This shows us latency buckets. This one will show us completed RPCs. And then also this is completed RPCs. The aggregation here is by rate. So this is, at this time, the service was really popular. We're hitting 4,000 requests per second. And then these are the stack driver traces that we've seen before, and also Google Stack Driver. And that's a client instrumented to give you pretty much the same, pretty much the same metrics and traces. Overall, you could instrument open census starting from starting from the request until your backend. Starting from your client until your backend. And also you could instrument database drivers like I did for MongoDB. You could also instrument your server itself. So I instrumented Caddy. And all this work is open source. I also made a demo for Java gRPC users. It's the equivalent of the Go tutorial. Please check it out. And also I made one for Python. And with that, sorry for all the rambling. I was just too excited, but thank you very much. That's all I have.
That's awesome. Thank you so much for sharing that. Does anybody have any questions? We are unmuted now.
So you mentioned that C# is coming soon.
Yeah.
What's the exact plan?
Yeah. So I believe I could mention this publicly. So Microsoft Microsoft is on board with Open Census, and they plan on rolling out a C# implementation. But there is a company, I believe it's Pivotal related. They rolled out a C# implementation already. But they haven't given us any guarantees that it is stable and if they'll be releasing it to Open Census. But the official one will be coming pretty soon. Thank you. Any other questions?
You've got some comments saying amazing stuff, so.
Oh, thank you.
I think many of us were reading. That's why we're quiet.
Yeah, it's amazing the blog posts and everything you've gotten out so quickly. So this is really great.
Yeah. Actually, I also meant to push out the one for C++, but there was something tricky about the build system. Although I'll be finished, I'll push out the C++ blog post and tutorial perhaps by tomorrow. But otherwise, I wrote the code already.
Awesome. Okay.
Oh, sorry, by the way. Sorry, April, for cutting you off.
Yeah, go ahead.
I actually meant to announce that out of the box, Open Census is integrated with gRPC Go and gRPC Java. So right now, you could just go copy and paste that tutorial in your code and it should just work. That's it.
Awesome.
So just out of curiosity, are you planning to make this kind of talk at some conference, or because I think it's really interesting. So I guess many other people would like to see.
Oh, for sure. I'm assuming you're in Sunnyvale, right?
Right now we are.
Okay. Yeah. This month, in mid-June, I'll make a talk. I'll present a talk at OSF.
Yeah, if anybody didn't see the KubeCon China and North America, which is in Seattle this year, the call for presentations just opened up this week for both of those. So definitely check those out. I'm not sure I don't know if we've got a lot of folks trying to go to the one in China, but I would imagine the North America one usually gets a a big turnout as well. All right. Well, thank you very much for all of this, the demo, the blog posts, and everything. This is really great. I know Open Census is really exciting and interesting for a lot of folks.
Oh, thank you very much. Thanks for the invitation and everyone for listening. Appreciate it.
Of course.
It was really good.
Thank you.
All right. So if I go back to the docs, we had a question about gRPC support for asyncio. I'm probably mispronouncing that.
Asyncio. I don't know in
Okay.
English. Yeah. First of all, Emmanuel, thank you for the presentation. It was really good. Yeah, I think it's a quick question, because you might know that there is an open issue in GitHub that I think was opened 2 years ago. I think it's there was some chats there, but nothing concrete. And I wanted to ask if there is any initiative to finally set up an asyncio client for, well, asyncio support for gRPC that allows us to run non-blocking programs. First of all, is about asking if if this initiative exists. Is there anybody have this information here? Sorry, I cannot hear you. Hi, sorry, I cannot hear you.
Hey, April.
I think it's mute. April?
Daniel, we can't hear you.
Sorry, guys, I think we lost I think you are mute. Hi. Hi, sorry, but I think you are mute. April, hi. Hi, you are mute. Wow.
Even their video seems lagged.
Hear the room. Hello.
Hello. April?
Everyone else has left the call.
Wow, we lost the call.
Well, that is interesting.
Yeah.
If you look at their screen,
Yeah, it's stuck. So
Yeah.
basically, they're cut
they
off.
are talking, but we lost the voice completely. Yeah. I know how. Can we ping them? Let me check. Can we ping them through the chat, maybe? Oh,
I just picked them. I think so. Kailas have responded
yeah.
that they are connecting back very soon.
Okay.
Google guys, can you hear us?
Hi.
Yeah, let me try and get them back.
Yeah, perfect.
That's pretty interesting.
I don't know if the answer was yes, exists an initiative or not.
oh, I guess I broke their screen. Rather, broke their Zoom.
Yeah, we can see them.
Yeah.
I can see the
Yeah.
okay.
April and team, can you hear us? No, I don't think so.
Oops.
Uh-oh.
Oops. maybe they can reconnect again the call. I think this is the only way to.
The video stream seems to be working very well.
Yeah.
Just I think so they have lost the audio. Maybe they are using another stream for the audio and the video.
I don't know.
Yeah, it seems so. This is what was mentioned on the chat that we are dialing again.
Yeah. Hi, April. Hi.
Why would they use a different voice between those two?
Hi.
Okay, is this working better now?
Yeah,
Yes,
we can hear you guys.
Okay.
Yes.
Woohoo.
So
Zoom.
we lost all of the conversation.
Okay.
But we.
So you
I
lost the part where Nathaniel promised to fix it, like right now?
But I am reading the answers in the Google Doc.
Yep. Yeah, that's roughly what was said so far.
Yeah, Zoom is not playing well today for some reason.
Yeah. Well, that's I think it's
I'm
good news.
Okay.
Yeah, because I think having, for example, G11 that already uses the EO manager that is exported by the library, or having also the Node.js implementation that uses the lib EO manager, I think the implementation for async IO, it's not rocket science, it's not peanuts, but it's something that can be done. So will be a good and really a good advantage for the Python asynchronous ecosystem. So this is something that me and I was also talking.
Everyone else has left the call.
Oh.
Goodbye.
Okay, I don't even know where that came from. So.
From Zoom. Yeah, I was. No, yes.
This is the day the computers took over.
Yeah, it looks like the Skynet is.
Yeah.
Yeah, I was saying that it's a fantastic news that if this is going to be something important for you the next quarter. Also, you have to say that for us, at least for me, and maybe also for my company, it's important. We also are thinking on put some efforts here. So I don't know. Maybe in the next weeks, if this initiative is still not started, maybe I can present something related how could be implemented, because maybe
that would be very interesting to us.
Okay, and then we can share a bit which could be the good solution, and if you believe that is something that can be worth it, maybe we reuse it, and maybe we can join efforts between all of us to try to make it as soon as possible.
Right, and just to add to that, have you seen the G event implementation that that got done like about a month ago?
Yeah, exactly. That was the point, because I remember that 1 year ago when I was visiting the same issue, I didn't realize it about the implementation of the abstraction of the EO manager. Maybe 2 years ago wasn't there. Then I saw the implementation for the Node.js, and then I saw the implementation for G11, and my mind was saying, wow, this can be implemented also for async.io using a pure and native client.
Yeah. Okay, good.
Are there any other questions that anyone has, or anything the computer would like to ask us since it's taking over? This is the day gRPC became sentient.
Okay, thank you very much.
All right, well, I don't see anything else in the working doc, so unless anyone on the call has anything else, we can skip 15 minutes back and chat again in a couple of weeks.
Okay, see you there.
All right. Thank you all for joining us today. I will get the recording, at the very least, of the demo. We got that, it looks like. So we'll get that up on our YouTube channel and can share that out with everyone later. And if you want to demo anything or share anything on our next meeting, please reach out. Thank you so much. We will chat soon.
All right. Thank you very much, everyone.
Goodbye. Bye.